Hello and good day everyone. My name is Sans Lawrence Palma, STEM 11 Empirical, and I will present to you my performance task in statistics and probability that is all about mean and variance of sampling distribution of the sample mean. Let's start with my given. The tables shown are the participants and their corresponding weights. As shown, TJ, my nephew, weighs 40 kilograms, Marga, my cousin, weighs 47 kilograms, Hans, which is me, weighs 59 kilograms, and Dandy, my older brother, weighs 60 kilograms. After we gather the data, we will proceed to our step 1, which is to compute the mean of the population. So in order to calculate the population mean, I use the formula population mean equals the summation of x divided by n, where x represents the weight of the participants or the elements of the population, and n represents the number of elements. By adding all the participants' weights and dividing it by 4, I obtain the answer 51.5 or simply 52. So, the population mean is 52. Step 2. Compute the variance of the population. Here, we can see a 3-column of table with the elements of the population, also denoted by x, on the first column. The difference between the x and the mean of the population on the second column, and the difference between the x and the mean of the population squared on the last column. First, the x here is 40. Then I subtracted it from 52, which is my population mean from the step 1 to get the answer -12. Finally, I squared it to get the answer 144. The same solution was used in the remaining cases, and then I added all the terms in the third column to get the answer 282. Finally, to compute the population variance, I use the formula summation of x minus population mean squared divided by n, so 282 divided by 4 is equal to 70.5 or simply 71. So, the variance of the population is 71. Third step. Determine the number of possible samples of size n equal to. Using the formula NCN, where capital N is equal to 4 and small letter n is equal to 2, there are 6 possible samples of size 2 that can be drawn. Step 4. List all the possible samples and their corresponding means. This table illustrates the possible samples along with the corresponding means. To find its mean, add the two numbers in each sample and divide it by 2. For example, 40 plus 47 is equals 87, and divide it by 2 to find its mean, which is 43.5. The same solution was used in the remaining cases. Step 5. Construct the sampling distribution of the sample means. This table is called as a sampling distribution of the sample means. In the first column is the sample mean followed by the frequency and probability. First, I arrange the sample mean from least to greatest and determine the frequency, which is number of times that the sample mean value appeared, and calculated the probability, which is the frequency of the sample mean over the total number of samples. Here, since 43.5 has only appeared once, the probability is 1/6. Same with the samples 49.5, 50, 53, 53.5, and 59.5, which also have the probability of 1/6. 6. Compute the mean of the sampling distribution of the sample means. So, to compute the mean of the sampling distribution of the sample means, I multiply the sample mean by its corresponding probability. Here, 43.5 is multiplied by 1/6, which is why I got 7.25. 49.5 multiplied by 1/6 is equals 8.25. 8.33, 8.83, 8.92, and 9.92 are the results of multiplying the number 50, 53, 53.5, and 59.5 by 1/6. And then we will add all the answers in the third column. 7.25 plus 8.25 plus 8.33 plus 8.83 plus 8.92 plus 9.2 is equals 51.5 or simply 52. So, the mean of the sampling distribution of the mean is 52. Step 7. Compute the variance of the sampling distribution of the sample means. I started by subtracting the population mean from each sample mean, then square their difference, then I finally multiply the results by the corresponding probability. In the third column, I obtain negative 8.5 by subtracting 54, which is my population mean, from 43.5 sample mean, and then I multiplied it twice by itself and obtained the answer 72.25. As shown in the fourth column, when 72.25 is multiplied by its corresponding probability, which is 1/6, the answer is 16.67. The same solution was applied on the remaining cases. And finally, we will add all the final results in the fifth column, which are 12.42 plus 1.42 plus 0.667 plus 0.167 plus 0.375 plus 9.375, and we will obtain 23.668. So, the variance of the sampling distribution of the sample mean is 23.668 or 23.67. The eighth and the last step. Construct the histogram for the sampling distribution of the sample mean. So, this histogram depicts the relation between sampling distribution probability and sample mean. As shown, the sample mean 43.5, 49.5, 50, 53, 53.5, and 59.5 have a probability of 1/6. That's all for my performance task in statistics and probability. I hope that you learned something in this video. Thank you.